The ground beneath the town of Grindavik didn't just shake, it ripped apart. In November 2023, thousands of residents were forced to flee their homes, leaving everything behind as magma, molten rock that had been lurking in the deep crust for centuries, began to hunt for a way out. When it finally broke the surface, it didn't emerge as a single, polite mountain peak. It tore open a fissure through the earth, sending fountains of fire hundreds of meters into the air and drowning modern infrastructure in a sea of black basalt. But this isn't just a tragedy for one town. It is a warning shot for an entire nation. For 800 years, the Reykjanes Peninsula, the very toe of Iceland that houses its international airport, its most famous tourist attractions, and its geothermal power supply, has been dead quiet. But that silence was a deception. We are not witnessing a freak accident or a momentary geological glitch. We are witnessing the start of a new era. A 1,000-year clock has just struck midnight. The dormant volcanoes of southwest Iceland have woken up, and according to the geological record, they aren't going back to sleep for another 2 to 4 centuries. This is the story of a modern society facing an ancient nightmare. It is a battle between human engineering and the raw, unstoppable force of the planet itself. And the question isn't whether the lava will stop coming. The question is, can we survive it? To really understand why this is happening right now, you have to understand that Iceland shouldn't really exist. By all rights, this part of the North Atlantic should be nothing but deep, dark ocean. But Iceland is a geological anomaly, a massive mistake on the map caused by the collision of two violent forces. First, there is the Mid-Atlantic Ridge. This is the divergent boundary where the North American and Eurasian tectonic plates are ripping away from each other. They drift apart at about the speed your fingernails grow, roughly 2 centimeters a year. Usually, this happens deep underwater, creating new crust in the crushing darkness of the ocean floor, forming the longest mountain range on Earth that almost nobody ever sees. But beneath Iceland, this ridge intersects with something else, a mantle plume. It's a column of superheated, buoyant rock rising from deep within the earth like a blowtorch held against the bottom of the crust. This hotspot creates a geological pressure cooker that has been left on high for millions of years. It pumps out magma on such a staggering scale that it has built a pile of lava thick enough to break the surface of the ocean and create an island. In fact, despite being smaller than the state of Kentucky, Iceland has produced a third of all the lava that has erupted onto Earth's surface in the last 500 years. It is the only place on the planet where a mid-ocean ridge rises above the waves, allowing you to literally walk between the separation zone of two continents. But here's where it gets terrifying. The tectonic stress on this peninsula doesn't release gradually. It works in cycles. Imagine the crust is a rubber band. For 800 to 1,000 years, the plates pull apart, stretching that rubber band tighter and tighter. The land quietly absorbs the strain, tension builds in the rock, invisible to the naked eye, and then the rubber band snaps. This is what we are seeing today. The crust has reached its breaking point. The accumulated tension of a millennium is being released in a violent cascade of rifting. Magma is surging into the fractures, forcing the land open. We know this because it has happened before, and the last time it happened, it nearly ended a civilization. In the year 874 AD, the Vikings first settled these shores. They were tough, resourceful navigators, but they were not prepared for what the ground had in store. They walked into a geological trap. Between the years 1210 and 1240, the peninsula erupted in what history calls the Reykjanes Fires. Medieval chronicles describe darkness at noon, fire rising from the sea, and widespread devastation. The eruptions poisoned the livestock with fluorine gas, choked the crops with ash, and pushed the early Icelandic settlements to the very brink of starvation. It was a time of terror that lasted for decades. Eventually, the fires stopped. The peninsula went dormant again, and for nearly 8 centuries, the people of Iceland forgot the true danger. They built a modern world on top of a sleeping dragon. Today, the Reykjanes Peninsula is the nerve center of the Icelandic economy. 80% of the country's population lives within an hour's drive of this area. They built the Blue Lagoon, a world-famous spa. They built the Keflavik International Airport, the gateway to Europe and America. And crucially, they built the Svartsengi Power Station, a geothermal marvel that provides hot water and electricity to 30,000 people. They built all of this assuming assuming the ground was solid. But in late 2019, the dragon woke up. It started with earthquakes. At first they were small, just a rattle in the dishes, but soon they multiplied. By early 2021, more than 40,000 earthquakes shook the region in a matter of weeks. This phenomenon is known as a seismic swarm, and it terrified the locals. It was the sound of the crust cracking. Just a few kilometers below the surface, magma was forcing its way up through the fractures in what geologists call a dike intrusion. The rock fractured, the magma flooded in, and the pressure built until it could no longer be contained. In March 2021, the ground finally gave way in a valley called Grindavík. A fissure ripped open, and a surreal glowing curtain of lava, 180 meters long, fountained into the air. It was the first eruption in this area in 800 years. At first, it was a tourist attraction. People hiked out to see the friendly volcano. But the geology didn't care about tourism. The eruptions didn't stop. They migrated. In 2022, and again in 2023, the fissures moved closer and closer to civilization until they were literally on the doorstep of Grindavik. So what does a modern nation do when the earth turns against it? You can't stop a tectonic plate. You can't plug a volcano. In the past, the only option was to run. But this is the 21st century, and Iceland decided to do something that sounded impossible. They decided to fight back. As the lava began to threaten the town and the vital power station, the Department of Civil Protection mobilized. They assembled a task force of geologists, engineers, and construction crews to attempt the largest lava defense project in human history. This wasn't about superstition. It was about science. The goal wasn't to stop the flow. Gravity and physics make that impossible. The goal was to steer it. They turned to engineers with backgrounds in hydrodynamics, people who usually model floods and river ice. They utilized simulation software, originally designed by the US Navy to predict water dam failures, and recalibrated it for molten rock. They calculated where the lava would flow, how fast it would move, and where it would pile up. Then they brought in the heavy armor. Fleets of massive bulldozers and excavators began working around the clock, scraping up the volcanic soil to build walls. These weren't just mounds of dirt. These were engineered berms, nearly 25 feet high and kilometers long, built with compacted basalt, gravel to resist heat, and armored with boulders to withstand the crushing pressure of the flow. But the engineers quickly learned that not all lava is the same, and this distinction was a matter of life and death. Some of the lava was what geologists call aya. It's chunky, rough, and viscous. When this hit the barriers, it piled up like geological porridge, thickening and threatening to breach the top of the walls. To stop this, you need a fortress. Other flows were pahoho, smooth, runny lava that behaves more like honey. Drone surveys showed this lava could flow over dams easily, but could be redirected using angled beams, guiding it away from danger rather than blocking it entirely. Armed with this data, they built a multi-kilometer ring of defense around the Svartsengi power station. And it worked. Drone footage from the recent eruptions shows the impossible. Rivers of molten basalt flowing at temperatures of 1,200 degrees Celsius, hitting these man-made walls and being deflected. The lava piled up, searching for a weakness, but the barriers held. The critical infrastructure that keeps the peninsula warm and lit was saved, not by luck, but by math, grit, and 24-hour construction shifts. However, this war has casualties. While the power plant was protected, parts of Grindavik were not. The barriers have limits. They cannot protect a town when a fissure opens directly beneath the streets. In late 2024, lava overran the car park of the famous Blue Lagoon Spa. This was a calculated sacrifice. The engineers knew they couldn't save everything, so they chose to save the buildings and the power plant, letting the car park be consumed. It is a stark reminder that while we can deflect nature, we cannot control it. This brings us to the uncomfortable reality of the future. The fires of the 13th century didn't stop after one or two eruptions. They pulsed on and off for 30 years. The geological cycle we have just entered suggests this level of activity could persist for 200, perhaps even 400 years. This isn't a temporary crisis. This is the new normal. This means that for the next 10 generations of Icelanders, fire season will be a regular part of life. The children born today in Reykjavik will grow up with the red glow of eruptions on the horizon. They will become the world's leading experts in disaster response, in rapid infrastructure repair, and in living alongside the volatile heartbeat of the planet. Plans are already being drawn up to relocate electricity masts, to bury pipelines deeper into the bedrock, and to redesign road networks for rapid rerouting. Artificial intelligence is being drafted to improve forecasting, giving residents those few precious extra minutes to evacuate. We are watching a real-time experiment in adaptation. Iceland is rewriting the textbook on how civilization interacts with geology. They are proving that while we are small compared to the forces of the earth, we are not helpless. The fires have returned. The cycle has reset. The land is being born anew, violent and bright. And as the world watches the lava fountains rise, we aren't just seeing destruction. We are seeing the raw, terrifying beauty of creation and the incredible resilience of the people who call this burning rock their home. It is a reminder that we live on a dynamic, restless planet, and sometimes the only way to survive is to change with it. If you want to keep following this geological saga and understand the forces shaping our world, make sure you hit that subscribe button. And I want to hear from you in the comments. Knowing the science and the risks, would you choose to live in a town protected by a wall of dirt against a volcano? Thanks for watching.